Hello friends, today we'll discuss about percentages. So what is percentage? A percentage definition of percentage literally means for every 100 or per 100. So for example, if uh, we say a percent means a divided by 100. This percent means divided by 100. Now when we say a percent of B, we mean A by 100 into B, or AB by 100. Now this is same as saying B percent of A, which is also equivalent to AB by 100. So percentage really means for every 100. So let's see some other concepts in this. Percentage ratio equivalent. Now if we remember few ratio and their percentage equivalent, it will be helpful for doing calculations. For example, half, if I have a ratio half, what is its percentage equivalent? Its percentage equivalent is equal to 50%. 50%. Half means 50%. So one third. One third is equal to 33.33%. One fourth is equal to, we know one half is 50%, one fourth is half of this, that is 25%. One fifth is 20%. One sixth is half of either this, half of this, one sixth is half of this, one sixth is half of one third. So one sixth is equal to half of this, that is 16.66%. Now 1/7 is 14.28%. 1/8 is half of 1/4. 1/4 is 25%. 1/8 will be 12.5%. 1/9 will be, one third of this. One third of this, because 1/9 means one third into one third. One third divided by 3, that is 1/9, right, which is nothing but 33.33% divided by 3, which is nothing but 11.11%. Now 1/10 is equal to 10%. 1/11 is equal to 9.09%. 1/12 is equal to half of 1/6. 1/6 is 16.66%, so 1/12 is equal to 8.33%. So 1/13th, you need to remember, it is 7.69%. So 1/14 is equal to half of 1/7, that is 7.14%. Right. So now 1/15 we got to remember. So 1/15 is equal to 1/5, we know, that is 20%. So 1/5 by 3 will be 1/15. So that is 20% by 3, that is 6.66%, that is 1/5. So if you need to remember only few fraction percentage equivalents, and you can deduce others from those. So this will help you while doing many calculations. For example, if you want to compute what is the value of 3/8, for example, if you want to compute what is the value of 3/8, right? So if I use the eraser, let me use the eraser here. So if we want to compute 3/8, for example, 3/8, let's say I want to compute 3/8. So 3/1, I know 1/8, I know 1/8 is, so 3/8 I want to compute. So 3/8 is nothing but 3 into 1/8. So 1/8 I know, 1/8 is 12.5 percent. So 3 into 12.5 percent, so that is nothing but 37.5%, right? So 3 by 8 is 37.5%. So this these calculations can help us do derive some results like this 3 by 8, maybe 5 by 7. 5 by 7 can be derived. We know 1 by 7. 1 by 7 is 14.28, so 5 by 7 will be 5 into 1 by 7. Similarly, I can deduce 9 by 11, for example. What is the percentage equivalent of 9 by 11? I know 1 by 11, so 9 by 11 will be equal to 9 into 1 by 11. So I can get those results. So this, if you remember this, it will help you doing a lot more calculations in data interpretation, DI, as well as in quantitative aptitude calculations. So let's move on and see other things. So there is something called as product stability. So what is this product stability? So let's see. So product of two quantities is equal to, when the product of two quantities is equal to the third quantity, for example, you can use this product stability ratio in situations where we have two quantities in multiplication which is equal to third quantity. For example, speed into time is equal to distance, price into consumption is equal to expenditure, or number of persons into days is equal to work done, or length into breadth is equal to area of rectangle, or in general, if we have product of A and B which is equal to P. So in such situations we can use this product stability ratio. What it says is, if one quantity in the product is increased by certain percentage, then the other quantity, that is B in this case, is required to be decreased by certain percentage in order to keep the product constant, right? So what it means is, if we increase A by some percentage, right, by some percentage, we have to decrease B by certain percentage in order to keep this product constant. If initially, if A, if we have A into B is equal to P, right? If we want to keep this constant, we don't want to change the product result of the product. But if we are in order to do that, if we increase A, so we have to decrease B in certain proportion in order to have this P constant, right? So that is called as product stability. See, if one quantity increases by certain percentage, other quantity has to be decreased by a proportion in order to keep this product constant. That is called as product stability. So this product stability has application in many areas, or many areas of quantitative aptitude. For example, we have its application in percentages, right? So let's see the application of this product stability in percentages. So here, if A is 25% more than B, then by how much percentage B is less than A? So A is 25% more. A is more by 25%, right, than B. So A is more by 25% means it is more by 1 by 4, right? A is more by 1 by 4. So B will be less than by how much percentage than A? So here, so let's see the calculation. If A into B is equal to P, now we are saying it is said that A is more by 25%. That means A is increasing by 1 by 4th of original A, right? So A is becoming 1 plus 1 by 4th of A. That means A is becoming 5/4 of A. We had original A, now it is becoming 5/4 of A. Now we have to have here B as 4 by 5, so that this 4 will cancel this 4 and this 5 will cancel this 5 in order to have A and B, because we want the end result as P. We want this P. So P will get only when we have A into B here. So now our A is becoming 5/4 of A. So here we should have 4/5, so that this 4 will cancel this 4 and this 5 will cancel this 5, so, and we'll have B here. And ultimately we have a into b here, right? So that means now a is becoming 5/4, so b will become 4/5. So b is becoming 1 minus 4/5. B is becoming 4/5. That's why it has to be reduced by 1 minus 4 by 5. That is 1 by 5. 1 by 5. So B has to be decreased by 1 by 5. That means if A is increasing by 1/4, B will decrease by 1/5. So in general, if A increases by 1 by n, if the increase is by 1 by n, increase is by 1 by n, so decrease has to be by 1 upon n plus 1. Decrease has to be 1 upon n plus 1. So let me make some space here. So if A is increasing by 1 by n, so B has to be decreased by 1 upon n plus 1. So the concept which we'll use here is if A increases by 1 upon n, B will decrease by 1 upon n plus 1. 1 upon n plus 1, right? Or if A can also decrease. If A decreases by 1 upon n, B will increase by 1 upon n minus 1. So this is the concept which we are going to use. If A increases by 1 by n, B will decrease by 1 upon n plus 1. If A decreases by 1 by n, B will increase by 1 upon n minus 1. So now here A is increased by 1 by 4, so B will decrease by 1 upon 5. So therefore B is 1/5 less than A, or B is 20%. 1/5 means 20% less than A. So B is 20% less than A. So let's see the second question. Selling price is 125 rupees 125 at a profit of 25%. What is the cost price? So selling price is 20%. That means selling price is 25% more. 25% more than cost price, right? Because we have 25% profit. So selling price is 125, which is 25% more than CP. So by how much CP is less than SP? So CP, so here SP is increasing, or SP is more by 25%. 25% means 1 by 4. So CP must be less than, so it is SP is increasing by 1 by 4th, right? So therefore CP must decrease by 1 by 5th. 1 by 5th of the SP. So CP is 1/5 less of 125. So CP, so 1/5 of 125. So that is nothing but 25, right? So therefore CP is 25 rupees less than SP. That means CP is equal to 125 minus 25. That is nothing but 100. So CP is 1/5 less. CP is 1/5 less. So SP is 25% more. CP will be, SP is 25% more than CP. So CP will be 20% less than SP. Right? So let's see another question. Application of this product stability. A person increases his speed by walking, speed of walking by 25%. The time taken reduces by 20 minutes in covering a certain distance. What is the actual time taken? So a person is increasing. Let's say if the speed was s in the beginning, now the new speed is increased by 25%. So speed is getting increased by, new speed is 25% more than the original speed. So when I increase my speed, the time will decrease in order to cover the same distance, right? So speed is getting increased by 25%. So the original time will reduce by, so speed is getting increased by 25% means 1 by 4. So the original time will decrease by 20% or 1/5. So speed is getting increased by 1 upon n. So time will decrease by 1 upon n plus 1. So speed is increasing by 1/4. So time will decrease by 1/5. So decreased time is given to us. So decreased time is given to us, that is 20 minutes. We are taking 20 minutes less than the original time. So 1/5 of the original time is equal to 20 minutes. So therefore original time t is equal to 20 into 5 is equal to 100 minutes. So original time required is 100 minutes. Next question. A person goes to his office from his home at a speed of 20 km per hour and gets late by 10 minutes. So here is his home and here is his office. So when he travels with a speed of 20 km per hour, he is 10 minutes late 10 minutes. Now when he increases his speed to 25 km, so speed is increased to 25 km, he is 20 minutes early, right? So the difference between times of reaching is 30 minutes. That means original time is getting reduced by 30 minutes, right? So the speed is increasing to 25 km from 20 kilometers. That means the increase is 25%. Increase in the speed is 25%. So speed is increased by 25%. 5 over 20 is 25%. So speed is increased by 25%. Therefore, the time has to be reduced for traveling the same distance, because we are increasing the speed. Definitely, time will be reduced to cover the same distance. So that time should be reduced by 20%, because speed is increasing by 25% means speed is increasing by 1/4. So therefore, time will be reduced by 1/5, that is 1 upon n plus 1. So decreased time is given to us. So 1/5 of the original time is given to us, that is 30 minutes time difference. Initially he was arriving 10 minutes late, now he is arriving 20 minutes early. That means time is getting reduced by half hour. So that is the time. So half hour. 1/5 of the original time is half hour. Therefore original time must be 5 by 2 hours or 2.5 hours. That is original time. Now we are asked what is the distance. We know the original speed 20 km per hour. We know the original time now. So the distance is equal to speed into time. So speed into time, which speed is 20 km per hour into 2.5, or 20 into 5 by 2, which is nothing but 50 km. So the distance from home to office is 50 kilometers. So speed increased by 1 upon n, time will decrease by 1 upon n plus 1. The decreased time we deduced from the given information, 30 minutes. So let's see other question. The application of this concept in time and work now. Here the efficiency of A is 25% more than B, right? When the efficiency is more, time taken will be less. So if the efficiency is more by 25% or 1/4, efficiency is more by 1/4, so time taken will be less, because time and efficiency are inversely proportional. Whenever two quantities are inversely proportional, if one increases by 1 upon n, other should decrease by 1 upon n plus 1 in order to keep the product constant. So time will be decreased by 1 upon n plus 1, that is 1 by 5, which is nothing but 20%. So time will be decreased by 20%. If efficiency of A efficiency is more, so time taken by A will be time taken by A will be less by 20%, right? So now B is taking 20 days to complete a work. Efficiency of A is more than B by 25%, and B is taking 20 days to complete a work. So A will take 20% less than the days taken by B. So A will take 20% less than this B. B is taking 20 days, so 20% of 20 is equal to 4, right? So B will take 4 less days than A, that is B will take 20 minus 4 is equal to 16 days. Okay, so let's see another questions. Another question. So here is the next question. Again from time and work. 20 men can do some work in 50 days, right? In how many days 25 men will do the same work? So 20 men and 25 men. Increase in men is 25%, because here 20 men, 25 men, 5 men are increased from 20. So 5 is nothing but 25% of this 20. So 25% in increase in men. So mens are increased by 25%. So certainly days taken will be less. More men, less days. So days taken will be less by 20%, right? So days taken will be 20% less with 20 men. So 20% of 50 is equal to 10. So days taken will be 10 less than this 50. So therefore days taken is equal to 50 minus 10 is equal to 40. So 40 days will be taken. Men are increasing from 20 to 25, right? So days taken will decrease from 50 to 40. Okay, the application of this product stability in rate of interest or simple interest. So rate of interest is 12.5% per annum simple interest. What is the principal if the amount obtained after 2 years is 1250? So the rate of interest is SI, that means this 12.5% will remain constant for 2 years, right? So in 2 years the total rate of interest will be 25%, right? So originally if the principal was whatever principal we had, it is becoming 25% more. The new principal is becoming 25% more than the original principal. That means new amount after 2 years is becoming 25% more than the principal, right? So this is the amount after 2 years, 25% more than this, because in 1 year 12.5%, in 2 years 25%, because it is simple rate, simple interest rate, right? It is constant every year. So for example, if we have 100 principal is 100, in the next year it will be 12 point in 2 years it will be 125, because the rate of interest is simple 12.5%. So it will be 25% for 2 years, right? So now here we are given this amount after 2 years as 1250. 1250 is the amount after 2 years, and this is 25% more than this principal. This amount is 25% more, so this principal must be 20% less than this amount. So amount is increasing by 25% or 1/4. So principal is less than amount by 20%, so that is 1/5. So principal is 1/5 less than the amount. So principal is equal to 1/5 less than 1250. 1/5 of 1250 is nothing but 250. So 250 less than amount. So that is principal is equal to 1250 minus 250, which is nothing but 1000. Okay, so let's see another question. In percentage, due to a price hike of 25%, now the concept here is price into consumption is equal to expenditure. Now the price is getting increased by 25%. Price is getting increased by 25% or 1/4. Therefore the consumption has to be decreased. Consumption has to be decreased by 1/5 in order to keep this expenditure constant. If we don't want to increase or decrease our expenditure, we have to decrease this consumption in the proportion of in certain proportion, that is by 1/5, right? So consumption has to be decreased. Original consumption has to be decreased by 1/5, right? So the new consumption will be 1/5 less than the original consumption because of price is increased by 1/4. So now here what we are given is 5 kg less sugar is available for rupees 100. So reduced sugar or reduced consumption is given to us, right? Because of this increase in price, we have to reduce our consumption by 5 kg, right, in order to keep the expenditure constant. So new consumption, which is reduced by 1/5, is new consumption. So 1/5 of the original consumption is equal to 5 kg, right? Because we are getting 5 kg less sugar for the same expenditure. We are getting 5 kg less sugar. So therefore, the original consumption must be 25 kg. Original consumption is 25 kg, right? So the price was that price for what was the original price, that is the question asked. So original consumption is 25 kg, original expenditure is 100 rupees. So the price is equal to expenditure upon consumption. So 100 by 25, that is 4 per kg, rupees 4 per kg. So the concept used here is consumption is increased by 1 by 4, sorry, price is increased by 1 by 4, consumption has to be decreased by 1 by 5. So decreased consumption is given to us, that is 5 kg. So 1/5 of the consumption is 5 kg, so the consumption is 25 kg. Therefore price is equal to original expenditure divided by original consumption, that is 4 kg. So let's see another concept, another question based on the same concept. The concept used here is, if we are increasing one quantity, the other quantity has to be decreased by the certain proportion. Now the application in mensuration, length of a rectangle is increased by 25%. Length into breadth is equal to area of rectangle. In fact, this concept can be used for any two-dimensional figure. If one is increasing by 1 by n, other has to be decreased by 1 upon n plus 1. So here the figure taken is rectangle. So length is increasing by 25%. So certainly this breadth has to be decreased by 20%. Breadth has to be decreased by 20% because it is increasing by 1/4. The breadth has to be decreased by 1/5 in order to keep this area constant, right? By what percentage should be the breadth decreased so that area remains constant? So the breadth has to be decreased by 1/5 or 20%. So these are some applications of this product stability in various topics of this quantitative aptitude. So we'll see more questions on other concept in the next video. So keep watching. Thank you.